Part I, Chemistry. 15. Chapter 2. Classification of matter, Grade 10. All the objects that we see in the world around us are made of matter. Matter makes up the air we breathe, the ground we walk on, the food we eat, and the animals and plants that live around us. Even our own human bodies are made of matter. Different objects can be made of different types of matter or materials. For example, a cupboard, an object, is made of wood, nails, and hinges, the materials. The properties of the materials will affect the properties of the object. In the example of the cupboard, the strength of the wood and metals make the cupboard strong and durable. In the same way, the raincoats that you wear during bad weather are made of a material that is waterproof. The electrical wire in your home are made of metal because metals are a type of material that is able to conduct electricity. It is very important to understand the properties of materials so that we can use them in our homes, in industry, and in other applications. In this chapter, we will be looking at different types of materials and their properties. The diagram below shows one way in which matter can be classified, grouped, according to its different properties. As you read further in this chapter, you will see that there are also other ways of classifying materials, for example, according to whether they are good electrical conductors. Matter. Mixturespuresubstances. Homogeneous heterogeneous elements compounds. Metals non-metals. Magnetic non-magnetic. Figure 2.1, the classification of matter. 2.1 Mixtures. We see mixtures all the time in our everyday lives. A stew, for example, is a mixture of different foods such as meat and vegetables. Seawater is a mixture of water, salt, and other substances, and air is a mixture of gases such as carbon dioxide, oxygen, and nitrogen. 17. 2.1 Chapter 2. Thus, definition, mixture. A mixture is a combination of more than one substance where these substances are not bonded to each other. In a mixture, the substances that make up the mixture are not in a fixed ratio. Imagine, for example, that you have a 250 milliliters beaker of water. It doesn't matter whether you add 20 grams, 40 grams, 100 grams, or any other mass of sand to the water, it will still be called a mixture of sand and water. Keep their physical properties. In the example we used of the sand and water, neither of these substances has changed in any way when they are mixed together. Even though the sand is in water, it still has the same properties as when it was out of the water. Can be separated by mechanical means. To separate something by mechanical means that there is no chemical process involved. In our sand and water example, it is possible to separate the mixture by simply pouring the water through a filter. Something physical is done to the mixture rather than something chemical. Some other examples of mixtures include blood, a mixture of blood cells, platelets, and plasma. Steel, a mixture of iron and other materials, and the gold that is used to make jewelry. The gold in jewelry is not pure gold but is a mixture of metals. The carat of the gold gives an idea of how much gold is in the item. We can group mixtures further by dividing them into those that are heterogeneous and those that are homogeneous. 2.1 Heterogeneous mixtures. A heterogeneous mixture does not have a definite composition. Think of a pizza, that is a mixture of cheese, tomato, mushrooms, and peppers. Each slice will probably be slightly different from the next because the toppings like the mushrooms and peppers are not evenly distributed. Another example would be granite, a type of rock. Granite is made up of lots of different mineral substances including quartz and feldspar. But these minerals are not spread evenly through the rock, and so some parts of the rock may have more quartz than others. Another example is a mixture of oil and water. Although you may add one substance to the other, they will stay separate in the mixture. We say that these heterogeneous mixtures are non-uniform, in other words, they are not exactly the same throughout. Definition, heterogeneous mixture. A heterogeneous mixture is one that is non-uniform and where the different components of the mixture can be seen. 2.8. Homogeneous mixtures. A homogeneous mixture has a definite composition and specific properties. In a homogeneous mixture, the different parts cannot be seen. A solution of salt dissolved in water is an example of a homogeneous mixture. When the salt dissolves, it will spread evenly through the water so that all parts of the solution are the same, and you can no longer see the salt as being separate from the water. Think also of a powdered drink that you mix with water. Provided you give the Container a good shake after you have added the powder to the water, the drink will have the same sweet taste for anyone who drinks it. It won't matter whether they take a sip from the top. 18. Chapter 2. Das 2.1 or from the bottom. The air we breathe is another example of a homogeneous mixture since it is made up of different gases which are in a constant ratio and which can't be distinguished from each other. Definition: homogeneous mixture. A homogeneous mixture is one that is uniform and where the different components of the mixture cannot be seen. An alloy is a homogeneous mixture of two or more elements, at least one of which is a metal, where the resulting material has metallic properties. Alloys are usually made to improve on the properties of the elements that make them up. Steel, for example, is much stronger than iron, which is its main component. 2.8.13 Separating mixtures. Sometimes it is important to be able to separate the mixture. There are lots of different ways to do this. These are some examples. Filtration. A piece of filter paper in a funnel can be used to separate the mixture of sand and water. Heating, evaporation. Sometimes, heating a solution causes the water to evaporate, leaving the other part of the mixture behind. You can try this using a salt solution. Centrifugation. This is a laboratory process which uses the centrifugal force of spinning objects to separate out the heavier substances from a mixture. This process is used to separate the cells and plasma in blood. When the test tubes that hold the blood are spun round in the machine, the heavier cells sink to the bottom of the test tube. Can you think of a reason why it might be important to have a way of separating blood in this way? Dialysis. This is an interesting way of separating a mixture because it can be used in some important applications. Dialysis works using a process called diffusion. Diffusion takes place when one substance in a mixture moves from an area where it has a high concentration to an area where its concentration is lower. When this movement takes place across a semi-permeable membrane, it is called osmosis. A semi-permeable membrane is a barrier that lets some things move across it but not others. This process is very important for people whose kidneys are not functioning properly, an illness called renal failure. Interesting. Normally, healthy kidneys remove waste products from the blood. When a person, fact has renal failure, their kidneys cannot do this anymore and this can be life-threatening. Using dialysis, the blood of the patient flows on one side of a semi-permeable membrane. On the other side there will be a fluid that has no waste products but lots of other important substances such as potassium ions. That the person will need waste products from the blood diffuse from where their concentration is high in the person's blood into the clean fluid on the other side of the membrane. The potassium ions will move in the opposite direction from the fluid into the blood. Through this process, waste products are taken out of the blood so that the person stays healthy. 19. Chapter 2. Thus, activity, investigation, the separation of a salt solution. Aim: to demonstrate that a homogeneous salt solution can be separated using physical methods. Apparatus: glass beaker, salt, water, retort stand, Bunsen burner. Method: 1. Pour a small amount of water, about 20 milliliters, into a beaker. 2. Measure a teaspoon of salt and pour this into the water. 3. Stir until the salt dissolves completely. This is now called a salt solution. This salt solution is a homogeneous mixture. 4. Place the beaker on a retort stand over a Bunsen burner and heat gently. You should increase the heat until the water almost boils. 5. Watch the beaker until all the water has evaporated. What do you see in the beaker? Salt solution. Water evaporates. When the solution is heated, H2O, salt crystals, remain at the bottom of the beaker. Stand, Bunsen burner. Results: the water evaporates from the beaker and tiny grains of salt remain at the bottom. Conclusion: the sodium chloride solution, which was a homogeneous mixture of salt and water, has been separated using heating and evaporation. Activity, discussion, separating mixtures. Work in groups of 3 to 4. Imagine that you have been given a container which holds a mixture of sand, iron filings, small pieces of iron metal, salt and small stones of different sizes. Is this a homogeneous or a heterogeneous mixture? In your group, discuss how you would go about separating this mixture into the 4 materials that it contains. Base, Chapter 2. 10.2. Exercise mixtures. 1. Which of the following substances are mixtures? A. Tap water. B. Brass and alloy of copper and zinc. C. Concrete. D. Aluminium. E. Coca-Cola. F. Distilled water. Though. In each of the examples above, say whether the mixture is homogeneous or heterogeneous. 2.2 Pure substances, elements and compounds. Any material that is not a mixture is called a pure substance. Pure substances include elements and compounds. It is much more difficult to break down pure substances into their parts, and complex chemical methods are needed to do this. 2.2. Elements. An element is a chemical substance that can't be divided or changed into other chemical substances by any ordinary chemical means. The smallest unit of an element is the atom. Definition: element. An element is a substance that cannot be broken down into other substances through chemical means. There are 112 officially named elements and about 117 known elements. Most of these are natural, but some are man-made. The elements we know are represented in the periodic table of the elements, where each element is abbreviated to a chemical symbol. Examples of elements are magnesium Mg, hydrogen H, oxygen O, and carbon C. On the periodic table, you will notice that some of the abbreviations do not seem to match the elements they represent. The element iron, for example, has the chemical formula Fe. This is because Fe elements were originally given Latin names. Iron has the abbreviation Fe because its Latin name is ferrum. In the same way, sodium's Latin name is natrium, Na, and gold's is aurum, O. 2.2. Compounds. A compound is a chemical substance that forms when two or more elements combine in a fixed ratio. Water, for example, is a compound that is made up of 2 hydrogen atoms for every 1 oxygen atom. Sodium chloride is a compound made up of 1 sodium atom for every chlorine atom. An important characteristic of a compound is that it has a chemical formula which describes the ratio in which the atoms of each element in the compound occur. Definition: compound. A substance made up of 2 or more elements that are joined together in a fixed ratio. Diagram 2.2 might help you to understand the difference between the terms element, mixture, and compound. Iron, Fe, and sulfur, S, are 2 elements. When they are added together, they 21. 2.3 Chapter 2. Thus, an atom. SS of the L's F. E. Ament sulfur S. E. F. E. F. S. Fe. S. An atom. Fe of the Ls meant iron. Fe. A mixture of iron and sulfur. F. E. F. E. S. 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 E. E. F. F. S. S. E. F. E. F. The compound iron sulfide. Koshtak FES Koshtak. Figure 2.2. Understanding the difference between a mixture and a compound. Form a mixture or iron and sulfur. The iron and sulfur are not joined together. However, if the mixture is heated, a new compound is formed, which is called iron sulfide. In this compound, the iron and sulfur are joined to each other in a ratio of 1:1. In other words, 1 atom of iron is joined to 1 atom of sulfur in the compound iron sulfide. Exercise: elements, mixtures and compounds. 1. In the following table, tick whether each of the substances listed is a mixture or a pure substance. If it is a mixture, also say whether it is a homogeneous or heterogeneous mixture. Substance mixture or pure homogeneous or heterogeneous mixture. Fizzy cold drink, steel, oxygen, iron filings, smoke, limestone. Though. In each of the following cases, say whether the substance is an element, a mixture or a compound. A Cu. B. Iron and sulfur. C. Al. D. H2SO4. E. SO3. 2.3 Giving names and formulae to substances. It is easy to describe elements and mixtures. But how are compounds named? In the example of iron sulfide that was used earlier, which element is named first and which ending is given to the compound name? In this case, the ending is "ide." The following are some guidelines for naming compounds. Bias. Chapter 2. 10.3. 1. The compound name will always include the names of the elements that are part of it. A compound of iron, Fe, and sulfur, S, is iron sulfide. A compound of potassium, K, and bromine, Br, is potassium bromide. A compound of sodium, Na, and chlorine, Cl, is sodium chloride. Though. In a compound, the element that is on the left of the periodic table is used first when naming the compound. In the example of sodium is a group 1 element on the left-hand side of the table, while chlorine is in group 7 on the right of the table. Sodium therefore comes first in the compound name. The same is true for and. Theme. The symbols of the elements can be used to represent compounds, e.g. and. These are called chemical formulae. In these three examples, the ratio of the elements in each compound is 1:1. So, for there is one atom of iron for every atom of sulfur in the compound. Char. A compound may contain compound ions. An ion is an atom that has lost positive ion or gained negative ion electrons. Some of the more common compound ions and their names are shown below. Name of compound ion formula. Carbonate CO32 Ghattav. Sulfate SO42 Ghattav. Hydroxide O Ghattav. Ammonium NH4 Jod. Nitrate NO3 Ghattav. Hydrogen carbonate HCO3 Ghattav. Phosphate PO43 Ghattav. Chlorate Ghattav. Cyanide CN Ghattav. Chromate Cro42 Ghattav. Permanganate Ghattav. Pach. When there are only two elements in the compound is often given a suffix ending -ide. You would have seen this in some of the examples we have used so far. For compound ions, when a non-metal is combined with oxygen to form a negative ion, an ion which then combines with a positive ion, cation, from hydrogen or a metal, then the suffix of the name will be .8 or .it. NO3 Ghattav, for example, is a negative ion which may combine with a cation such as hydrogen or a metal like potassium. The No Ghattav 3 anion has the name nitrate. SO23 Ghattav in a formula is sulfite, e.g. sodium sulfate. SO24 Ghattav is sulfate and PO34 Ghattav is phosphate. Che. Prefixes can be used to describe the ratio of the elements that are in the compound. You should know the following prefixes: mono 1, di 2, and tri 3. CO, carbon monoxide, there is one atom of oxygen for every one atom of carbon. NO2, nitrogen dioxide, there are two atoms of oxygen for every one atom of nitrogen. SO3, sulfur trioxide, there are three atoms of oxygen for every one atom of sulfur. Important. When numbers are written as subscripts in compounds, i.e. they are written below the element symbol, this tells us how many atoms of that element there are in relation to other elements in the compound. For example, in nitrogen dioxide, there are two oxygen atoms for every one atom of nitrogen. In sulfur trioxide, SO3, there are three oxygen atoms for every one atom of sulfur in the compound. Later, when we start looking at chemical equations, you will notice that sometimes there are numbers before the compound name. For example, H2O means that there are two molecules of water and that in each molecule there are two hydrogen atoms for every one oxygen atom. 23.3 Chapter 2. Thus, exercise, naming compounds. 1. The formula for calcium carbonate is: A. Is calcium carbonate a mixture or a compound? Give a reason for your answer. B. What is the ratio of Ca-CO atoms in the formula? 2. Give the name of each of the following substances: A, B, C, D, NO2, E, NH4OH. F. Theme. Give the chemical formula for each of the following compounds: A. Potassium nitrate. B. Sodium iodide. C. Barium sulfate. D. Nitrogen dioxide. E. Sodium monosulfate. Char. Refer to the diagram below showing sodium chloride and water and then answer the questions that follow. A. What is the chemical formula for water? B. What is the chemical formula for sodium chloride? C. Label the water and sodium chloride in the diagram. D. Which of the following statements most accurately describes the picture? I. The picture shows a mixture of an element and a compound. E. The picture shows a mixture of two compounds. E. The picture shows two compounds that have been chemically bonded to each other. Pach. What is the formula of this molecule? A C6H2O BC2H6O C2C6HOD 2CH6O HH HCCOH H H 24. Chapter 2. 10.4 2.4 Metals, semi-metals and non-metals. The elements in the periodic table can also be divided according to whether they are metals, semi-metals or non-metals. On the right-hand side of the periodic table is a dark zigzag line. This line separates all the elements that are metals from those that are non-metals. Metals are found on the left of the line and non-metals are those on the right. Metals, semi-metals and non-metals all have their own specific properties. 2.4.1 Metals. Examples of metals include copper, Cu, zinc, gold, ore, and silver, Ag. On the periodic table, the metals are on the left of the zigzag line. There are a large number of elements that are metals. The following are some of the properties of metals. Thermal conductors. Metals are good conductors of heat and are therefore used in cooking utensils such as pots and pans. Electrical conductors. Metals are good conductors of electricity and are therefore used in electrical conducting wire. Shiny metallic luster. Metals have a characteristic shiny appearance and are often used to make jewelry. Malleable. This means that they can be bent into shape without breaking. Ductile. Metals, such as copper, can stretched into thin wire, which can then be used to conduct electricity. Melting point. Metals usually have a high melting point and can therefore be used to make cooking pots and other equipment that needs to become very hot without being damaged. You can see how the properties of metals make them very useful in certain applications. Activity, group work, looking at metals. 1. Collect a number of metal items from your home or school. Some examples are listed below. Hammer, wire, cooking pots, jewelry, burglar bars, coins, dough. In groups of 3 to 4, combine your collection of metal objects. Theme. What is the function of each of these objects? 4. Discuss why you think metal was used to make each object. You should consider the properties of metals when you answer this question. 25. 2.5 Chapter 2. Thus, 2.4.2 Non-metals. In contrast to metals, non-metals are poor thermal conductors, good electrical insulators, meaning that they do not conduct the electrical charge and are neither malleable nor ductile. The non-metals are found on the right-hand side of the periodic table and include elements such as sulfur S, phosphorus P, nitrogen N, and oxygen O. 2.4.3 Semi-metals. Semi-metals have mostly non-metallic properties. One of their distinguishing characteristics is that their conductivity increases as their temperature increases. This is the opposite of what happens in metals. The semi-metals include elements such as silicon C and germanium K. Notice where these elements are positioned in the periodic table. 2.5 Electrical conductors, semiconductors and insulators. An electrical conductor is a substance that allows an electrical current to pass through it. Many electrical conductors are metals, but non-metals can also be good conductors. Copper is one of the best electrical conductors, and this is why it is used to make conducting wire. In reality, silver actually has an even higher electrical conductivity than copper, but because silver is so expensive, it is not practical to use it for electrical wiring because such large amounts are needed. In the overhead power lines that we see above us, aluminium is used. The aluminium usually surrounds a steel core which adds tensile strength to the metal so that it doesn't break when it is stretched across distances. Occasionally gold is used to make wire, not because it is a particularly good conductor, but because it is very resistant to surface corrosion. Corrosion is when a material starts to deteriorate at the surface because of its reactions with the surroundings, for example oxygen and water in the air. An insulator is a non-conducting material that does not carry any charge. Examples of insulators would be plastic and wood. Do you understand now why electrical wire are normally covered with plastic insulation? Semiconductors behave like insulators when they are cold and like conductors when they are hot. The elements silicon and germanium are examples of semiconductors. Definition: conductors and insulators. A conductor allows the easy movement or flow of something such as heat or electrical charge through it. Insulators are the opposite to conductors because they inhibit or reduce the flow of heat, electrical charge, sound edge through them. Activity, experiment, electrical conductivity. Aim: to investigate the electrical conductivity of a number of substances. Apparatus: 2 or 3 cells. Light bulb. Crocodile clips. Wire leads. A selection of test substances, e.g. a piece of plastic, aluminium can, metal. Pencil sharpener, metal magnet, wood, chalk. 26. Chapter 2. 10.2 Battery. B. L. U. B. T. H. G. I. L. Test substance. X. Crocodile clip. Method. 1. Set up the circuit as shown above so that the test substance is held between the 2 crocodile clips. The wire leads should be connected to the cells and the light bulb should also be connected into the circuit. 2. Place the test substances one by one between the crocodile clips and see what happens to the light bulb. Results. Record your results in the table below. Test substance metal, non-metal. Does bulb conductor or glow? Insulator. Conclusions. In the substances that were tested, the metals were able to conduct electricity, and the non-metals were not. Metals are good electrical conductors and non-metals are not. 2.6 Thermal conductors and insulators. A thermal conductor is a material that allows energy in the form of heat to be transferred within the material without any movement of the material itself. An easy way to understand this concept is through a simple demonstration. Activity, demonstration, thermal conductivity. Aim. To demonstrate the ability of different substances to conduct heat. Apparatus. 27. 2.6 Chapter 2. Thus, you will need 2 cups made from the same material, e.g. plastic, a metal spoon and a plastic spoon. Method. Pour boiling water into the 2 cups so that they are about half full. At the same time, place a metal spoon into 1 cup and a plastic spoon in the other. Note which spoon heats up more quickly. Results. The metal spoon heats up more quickly than the plastic spoon. In other words, the metal conducts heat well, but the plastic does not. Conclusion. Metal is a good thermal conductor, while plastic is a poor thermal conductor. This explains why cooking pots are metal, but their handles are often plastic or wooden. The pot itself must be metal so that heat from the cooking surface can heat up the pot to cook the food inside it, but the handle is made from a poor thermal conductor so that the heat does not burn the hand of the person who is cooking. An insulator is a material that does not allow a transfer of electricity or energy. Materials that are poor thermal conductors can also be described as being good insulators. Interesting. Water is a better thermal conductor than air and conducts heat away from the fact body about 20 times more efficiently than air. A person who is not wearing a wetsuit will lose heat very quickly to the water around them and can be vulnerable to hypothermia. Wetsuits help to preserve body heat by trapping a layer of water against the skin. This water is then warmed by body heat and acts as an insulator. Wetsuits are made out of closed-cell foam neoprene. Neoprene is a synthetic rubber that contains small bubbles of nitrogen gas when made for use as wetsuit material. Nitrogen gas has very low thermal conductivity, so it does not allow heat from the body or the water trapped between the body and the wetsuit to be lost to the water outside of the wetsuit. In this way, a person in a wetsuit is able to keep their body temperature much higher than they would otherwise. Activity, investigation, a closer look at thermal conductivity. Look at the table below, which shows the thermal conductivity of a number of different materials, and then answer the questions that follow. The higher the number in the second column, the better the material is at conducting heat, i.e. it is a good thermal conductor. Remember that a material that conducts heat efficiently will also lose heat more quickly than an insulating material. 28. Chapter 2. 10.7 Material thermal conductivity, W.K. Silver 429. Stainless steel 16. Standard glass 1.05. Concrete 0.922. Red brick 0.69. Water 0.58. Snow 0.25 to 0.5. Wood 0.04 to 0.12. Polystyrene 0.03. Air 0.024. Use this information to answer the following questions. 1. Name 2 materials that are good thermal conductors. 2. Name 2 materials that are good insulators. 3. Explain why. A cooler boxes are often made of polystyrene. B. Homes that are made from wood need less internal heating during the winter months. C. Igloos, homes made from snow, are so good at maintaining warm temperatures even in freezing conditions. Interesting. It is a known fact that well-insulated buildings need less energy for heating than fact. Do buildings that have no insulation. 2 building materials that are being used more and more worldwide are mineral wool and polystyrene. Mineral wool is a good insulator because it holds air still in the matrix of the wool so that heat is not lost. Since air is a poor conductor and a good insulator, this helps to keep energy within the building. Polystyrene is also a good insulator and is able to keep cool things cool and hot things hot. It has the added advantage of being resistant to moisture, mold and mildew. Remember that concepts such as conductivity and insulation are not only relevant in the building, industrial and home environments. Think, for example, of the layer of blubber or fat that we find in animals. In very cold environments, fat and blubber not only provide protection but also act as an insulator to help the animal to keep its body temperature at the right level. This is known as thermoregulation. 2.7 Magnetic and non-magnetic materials. We have now looked at a number of ways in which matter can be grouped, such as into metals, semi-metals and non-metals, electrical conductors and insulators, and thermal conductors and insulators. One way in which we can further group metals is to divide them into those that are magnetic and those that are non-magnetic. Definition: magnetism. Magnetism is one of the phenomena by which materials exert attractive or repulsive forces on other materials. 29.8 Chapter 2. Thus, a metal is said to be ferromagnetic if it can be magnetized, i.e., made into a magnet. If you hold a magnet very close to a metal object, it may happen that its own electrical field will be induced and the object becomes magnetic. Some metals keep their magnetism for longer than others. Look at iron and steel, for example. Iron loses its magnetism quite quickly if it is taken away from the magnet. Steel, on the other hand, will stay magnetic for a longer time. Steel is often used to make permanent magnets that can be used for a variety of purposes. Magnets are used to sort the metals in a scrapyard, in compasses to find direction, in the magnetic strips of videotapes and ATM cards where information must be stored, in computers and TVs, as well as in generators and electric motors. Activity, investigation, magnetism. You can test whether an object is magnetic or not by holding another magnet close to it. If the object is attracted to the magnet, then it too is magnetic. Find some objects in your classroom or your home and test whether they are magnetic or not. Then complete the table below. Object magnetic or non-magnetic. Activity, group discussion, properties of materials. In groups of 4 to 5, discuss how our knowledge of the properties of materials has allowed society to develop advanced computer technology, provide homes with electricity, find ways to conserve energy. 2.8 Summary. All the objects and substances that we see in the world are made of matter. This matter can be classified according to whether it is a mixture or a pure substance. A mixture is a combination of one or more substances that are not chemically bonded to each other. Examples of mixtures are air, a mixture of different gases, and blood, a mixture of cells, platelets, and plasma. The main characteristics of mixtures are that the substances that make them up are not in a fixed ratio, they keep their individual properties, and they can be separated from each other using mechanical means. 30. Chapter 2. 10.8. A heterogeneous mixture is non-uniform and the different parts of the mixture can be seen. An example would be a mixture of sand and salt. A homogeneous mixture is uniform and the different components of the mixture can't be seen. An example would be a salt solution. A salt solution is a mixture of salt and water. The salt dissolves in the water, meaning that you can't see the individual salt particles. They are interspersed between the water molecules. Another example is a metal alloy such as steel. Mixtures can be separated using a number of methods such as filtration, heating, evaporation, centrifugation, and dialysis. Pure substances can be further divided into elements and compounds. An element is a substance that can't be broken down into simpler substances through chemical means. All the elements are recorded in the periodic table of their elements. Each element has its own chemical symbol. Examples are iron, Fe, sulfur, S, calcium, Ca, magnesium, Mg, and fluorine, F. A compound is a substance that is made up of two or more elements that are chemically bonded to each other in a fixed ratio. Examples of compounds are sodium chloride, iron sulfide, calcium carbonate, and water. When naming compounds and writing their chemical formula, it is important to know the elements that are in the compound, how many atoms of each of these elements will combine in the compound, and where the elements are in the periodic table. A number of rules can then be followed to name the compound. Another way of classifying matter is into metals, e.g. iron, gold, copper, semi-metals, e.g. silicon and germanium, and non-metals, e.g. sulfur, phosphorus, and nitrogen. Metals are good electrical and thermal conductors, they have a shiny luster, they are malleable and ductile, and they have a high melting point. These properties make metals very useful in electrical wire, cooking utensils, jewelry, and many other applications. A further way of classifying matter is into electrical conductors, semiconductors, and insulators. An electrical conductor allows an electrical current to pass through it. Most metals are good electrical conductors. An electrical insulator is not able to carry an electrical current. Examples are plastic, wood, cotton material, and ceramic. Materials may also be classified as thermal conductors or thermal insulators depending on whether or not they are able to conduct heat. Materials may also be either magnetic or non-magnetic. Exercise summary. 1. For each of the following multiple choice questions, choose one correct answer from the list provided. A. Which of the following can be classified as a mixture? I. Sugar. E. Table salt. E. Air. If iron. B. An element can be defined as 31. 2.8 Chapter 2. Thus, I. A substance that cannot be separated into two or more substances by ordinary chemical or physical means. E. A substance with constant composition. E. A substance that contains two or more substances in definite proportion by weight. If. A uniform substance. Though. Classify each of the following substances as an element, a compound, a solution. Homogeneous mixture or a heterogeneous mixture: salt, pure water, soil, salt water, pure air, carbon dioxide, gold and bronze. Theme. Look at the table below. In the first column, A is a list of substances. In the second column, B is a description of the group that each of these substances belongs in. Match up the substance in column A with the description in column B. Column A: iron, H2S. Sugar solution: sand and stone steel. Column B: a compound containing two elements. A heterogeneous mixture. A metal alloy. An element. A homogeneous mixture. Char. You are given a test tube that contains a mixture of iron filings and sulfur. You are asked to weigh the amount of iron in the sample. Suggest one method that you could use to separate the iron filings from the sulfur. B. What property of metals allows you to do this? 5. Given the following descriptions, write the chemical formula for each of the following substances. A silver metal. B. A compound that contains only potassium and bromine. C. A gas that contains the elements carbon and oxygen in a ratio of 1:2. Che. Give the names of each of the following compounds. A. B. CSO2. Sat. For each of the following materials, say what properties of the material make it important in carrying out its particular function. A. Tar on roads. B. Iron burglar bars. C. Plastic furniture. D. Metal jewelry. E. Clay for building. F. Cotton clothing. But these. Chapter 3. What are made of? There are